Hi everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is minimum difficulty of a job schedule, and it is a hard level problem. So the problem might seem a little bit difficult, but once you realize what the problem actually is, you'll be able to solve it easily. The only issue is like visualizing the DP states. So I've given it out. This is a DP problem, and the problem says that we have been given a schedule of lists of jobs, right? So let's say this is the list of jobs, and we want to perform all the jobs in this particular order only. That means job 6 has to be performed first, only then job 5 can be performed, then job 4 can be performed, and so on. The total number of days we have is 2. We have to perform at least one job on every single day, right? And they have defined a particular term, maximum difficulty. Yeah. So for each day, the difficulty of the job is defined as the maximum difficulty on that particular day, right? So for day 1, you see that the difficulty is 6, and for day 2, the difficulty is 1. Now at the end, you have to sum all of these difficulties across all the days, and the sum of these difficulties will be your answer. So you want to minimize this value of the answer, and this is the whole problem. So basically, you have been given some jobs, you want to divide them into certain days. For each day, the maximum value will be its difficulty. We have to sum all of these difficulties and make sure that the answer is minimum, right? Now, how can we actually solve this problem? We are going to solve this problem with DP, and I'm going to use a two-dimensional DP. So let us say I have DP of ij. So I'm going to define these DP states first. I denotes the index of my job, and j denotes the day of the job, right? So out of the d days, on which day I currently am. So I and j are going to denote the dp of ij, together are going to denote the best answer if I start from the ith day, ith job and the jth day, right? So basically, let's say I have 10 jobs and 5 days, right? So these are the dimensions of my DP. My final answer will be on DP of 0 0. Why? Because I am going to start from the 0th day, and I am going to start from the 0th job and the 0th day. Let's say I want to find out the answer if I would have started from job 2 and day 3. So this will be stored in DP of 2 3, right? This is what I mean by this DP array. Now I have discussed what will be the answer. It will be DP of 0 0. Why? Because I am going to start from the 0th job on the 0th day, right? Now what will be the base case? So if I have completed all the jobs, that will be n jobs, and I have completed all the days. In this particular case, the answer is 0 because I have successfully completed all the jobs, right? And for all other values of DP of n, let's say I is here, the answer will be infinity. Why? Because I have completed all the jobs, but there are still some days left, right? So the answer should be infinity because this is not a valid case. Again, if I am on some particular job but I have exhausted the number of days, the answer should again be infinity, right? Because I have not completed my jobs but I have exhausted my number of days. So again the answer is infinity, right? So these are the 3 base cases that we had to discuss. Now let us discuss how our transition will look like. So I am just writing the memoized code or the recursive code. So I have 2 values int, ij, right? Now the very first condition is if I is equals to n or j is equals to d, right? So if both of them are equal together, then in this particular case I am going to return 0 because this is a valid case, and there will be no further summation. Otherwise I am going to return infinity because I have exhausted one of the 2 things that are essential for doing this particular task, right? Now if my current state is memoized, if dp of ij is not equal to -1, I am directly going to return dp of ij. Now how do I make the transitions? So I am starting from position I. For the current day, I can take multiple jobs, right? I do not I do not know currently how many jobs I'm going to take, but I can take multiple jobs. And let us just traverse through all the possible cases that I can take for the current day. So let's say I initialize my max with 0. I initialize my, let's say, k with I. K can obviously be less than n and k plus plus. So let's say now I decide to take the kth job and I will try to figure out what will be the answer. So my max is going to change. My max is going to change by max of max comma, let's say, jobs of k, right? And if I take the current job in the current day and like leave all the remaining jobs for the rest of the days, my answer will be dp of ij is equals to minimum of dp of ij comma max plus dp of I plus 1 j plus 1. So you see what I am trying to do here is, I know that I am going to start from day I and I am currently on day j, right? These are the constraints of my dp, but I do not know how many further jobs I'm going to take on the current day. So what I did was, I'm just going to traverse through all those values, right? Instead of thinking about how many jobs I'm going to take on the current day, I'm just going to traverse through all the values possible, right? So I'm defining my max as maximum of the current job and the maximum value that I had, right? Considering I take the jobs till this particular index k, I'll try to figure out my best answer. So dp of ij is equals to minimum of dp of ij, comma maximum of, because this is now the maximum among this particular range. I started from I went till k, right? And plus dp of I plus 1 j plus 1. Why I plus 1? So it should not actually be I plus 1, it should be k plus 1, because I am considering all the jobs till k, right? So the next value should be k plus 1, and I have considered all the jobs till k for the jth day, so the number of days or the day should also increase, right? So I can write it as not dp but helper function, right? Since this is a memorized code or the recursive code, I can write helper of k plus 1 j plus 1. So that means starting from I am trying to consider all the jobs till index k. So that is why the next job has to be at k plus 1 and the number of days will also increase by j plus 1, right? Now what I do, I come back here and then I just return dp of ij, right? So you see how simple this code was. The only difficult part is visualizing this particular thing, right? The only reason this is a hard level problem, because it is not very simple to visualize this particular part, that you can start from the ith job and the dth day or the jth day, and then you can try to figure out, try all the cases taking different number of jobs for the current day and figuring out the minimum among them, right? So that is exactly what I have done here. I have taken first of all initialize n with a job difficulty size array, and then I have taken infinity to be a very big value, that is 1e5 in this particular case. So I believe this should work because the number of days is 10 and the maximum job difficulty is also 1000. So it can only, the maximum sum can only go up to 10 to the power 4, right? So that is why I have taken 10 to the power 5 here. Now I am initializing a double dimensional dp of size n plus 1 cross d plus 1. I have already said that I am going to initialize all the value with infinity, and only dp of nd will be equal to 0, because this signifies a valid test case when I have exhausted all the days as well as all the jobs together, right? So you see I had this condition here where both of them are like I is equals to n and j is equals to d, only then I return 0. If one of them has like finished, the answer will be infinity, right? So now you can see that inside this particular part I have initialized max with 0, so this is max with 0, and I have the exact same for loop that I have written in this particular code. The only difference is I have replaced this helper function with dp of k plus 1 j plus 1, right? Now what I am going to do here is I am going to define these particular values, that is the for loops. So this is the only difference between the recursive code and the iterative code. The middle part is the same, the middle logic is the same, the difference is in the for loops. So here I can see that my answer of dp of I depends on some bigger value than I, right? So you see that the k is equals to I and then it keeps on increasing. So that means some bigger value than I has to be computed before computing I. That is why I have taken I in reverse order. As far as j is considered in this particular problem, it doesn't really matter whether we initialized j from 0 to less than d or d minus 1 till greater than minus 1. because like for each of these constant I, the value of j does not change, right? Whenever the j changes, the I also changes, and that we have already taken care of. So even if I replace this by j is starting from, let me just replace this. So j is starting from 0, j is less than d, and j plus plus, it should still work fine, right? And at the end, I'm checking whether dp of 0 0, at which my answer is supposed to be, is greater than or equals to infinity, then I return -1, otherwise I return dp of 0 0. So let me just submit this quickly and show you that this particular code works. So you see, it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.